So everyone talks about predicting using big data, neural networks, deep learning. All sounds very profound, and I wanted to demystify this for you. So really, anytime you have two data points, you fit a line between them. Every child knows just knows how to do that. If you got 3 points, you can draw a curve through them. So these are all simple ways of fitting a curve to data. Now, sometime later, we start fitting complex curves, polynomials to data. Right? Everybody knows how to do that also. We call them regression. Now, people some time ago figured out that the brain actually interpolates, and we actually fit data. And we do this not through using polynomials, but we use neurons, collection of neurons that fire together, wire together, etc., and they in effect absorb complex patterns. So people said, well, if we could mimic how the brain fits curves to data, can we mimic that really well mathematically? Those ways of fitting curves to data using methods the way our biology does that are called neural networks. Simply put, if you have polynomials, you replace the polynomial with a similar function. It's called a sigmoidal function, right? And you have collections of neurons that in effect try to create regressions or input-output models of data. So if you have some inputs and some outputs, you could fit a curve using this technique called a neural network. A neural network typically has 3 layers: an input layer, an output layer, and what is called a hidden layer. Now, in the old days of doing neural networks, they all used to be manageable. A few neurons in the input layer, a few neurons in the output layer, and a few more in the hidden layer. That's typically how we would all do neural networks in the old days. And somebody came and said, well, you know what? What if we had a boatload of neurons in the input layer, a boatload of neurons in the output layer, and not just one hidden layer, but a boatload of hidden layers? Now, these boatloads of neurons in input and output and hidden ones are called deep learning. That's really the fundamental difference. A more grand, complicated, simple neural network is called a deep learning network. Each of these neurons in the layer are comprised of functions, typically sigmoidal functions, saturation functions, radial basis functions, etc. And you could build very complicated functions also, right? So they become very effective, nonlinear, discontinuous modelers. So in effect, you take simple linear regression and extend it out to neural networks, which are, again, what I say, are glorified regressors, glorified modelers of input-output data. That's all there is to it. Neural networks and deep learning neural networks.